Hello everyone, welcome back. This is part 5 of the design patterns tutorial. In this session we will discuss differences between lazy and eager initialization, singleton with eager loading, and how to use lazy keyword with singleton design pattern. Please refer to the previous parts of the singleton tutorial before proceeding. In the previous session, we have discussed about thread safety issues that may occur with the lazy initialization. We have also discussed how to overcome them by adding double check locking mechanism in the getInstance property. After these changes, we have created a new thread safe lazy initialization from our base singleton version. Basically, the lazy initialization of an object improves the performance and avoids unnecessary computation till the point the object is accessed. Further, it also reduces the memory footprint during the startup of the program. Reducing the memory footprint will help the application to load faster. Now you may be wondering why and when we need to use lazy initialization. Now let's assume a situation where we need to assign some static properties in the singleton class and those properties need to be retrieved from the database. In those situations, we tend to use lazy initialization as we do not need to retrieve these values till the singleton object is accessed. That means using lazy initialization depends on how heavy is the singleton instantiation and what are the dependence properties or methods that need to be loaded or assigned along with the singleton instantiation. If this is not very clear at this moment, don't worry. We are going to take a deep dive into those situations with the real world examples that we are going to demo in the next sessions. Now, after all of this, you may have a question going in your mind, what if I don't need to use the lazy initialization? Depending on the situation, we can enhance the current version of the singleton pattern to a non-lazy loading pattern. Or to simplify, let's call it as eager loading pattern. What is eager loading pattern? Eager loading is nothing but to initialize the required object before it's being accessed, which means we instantiate the object and keep it ready and use it when we need it. Let's see how we can do that. Let's switch to Visual Studio. Let's see how we can convert the singleton class from the lazy initialization to non-lazy initialization. In order to achieve lazy or eager loading, we need to follow 3 simple steps. In step 1, we need to change this null initialization to new singleton instance. In step 2, we need to change this instance property to read only. Now let's compile this application. Look at that. Compilation failed, stating that the static read-only field cannot be assigned again. Now that we have already initialized the singleton instance, we don't need to instantiate it again in the getInstance property. So in the step 3, let's remove the double check locking code and just return the instance. Let's also remove this static object that we have created earlier. Now let's run this application. Now look at that. The runtime has hit the getInstance property twice due to parallel invoke. Let's run the application again. If you observe the output, the counter value is still at 1. This proves that the eager loading has created only one singleton instance. Now, after all these changes, you may be thinking how it is thread safe. To answer that, the common language runtime takes care of the variable initialization and its thread safety. Hence, we don't need to write any explicit coding for thread safety. Let's stop the application and switch back to our main code. Now that we understand the eager loading very well, let's see how we can modify this eager loading to lazy initialization using lazy keyword, which is available in .NET Framework 4.0 and above. Lazy keyword provides support for lazy initialization. In order to make a property as lazy, we need to pass the type of object to this lazy keyword, which is being lazily initialized. Now let's wrap the singleton with the lazy keyword. New lazy singleton. The highlighted code will just wrap the singleton object in a lazy manner. In order to create the singleton instance, we need to create a new singleton instance using a lambda expression as a delegate. This is how we need to do that. Now let's compile the application. Look at that. There is a compilation error stating that we cannot implicitly convert the type lazy to singleton. Now, in order to access a singleton object, we need to use instance.value. Let's run this application. Look at that. The counter value is at 1, proving the lazy keyword has created only one instance of the singleton object. By default, lazy objects are thread safe. In multi-threaded scenarios, the first thread which tries to access this value property will take care of thread safety when multiple threads are trying to access the get instance at the same point of time. Therefore, it does not matter which thread tries to initialize the object or if there are any thread race conditions that are trying to access this get instance property. Now we hope you are familiar with eager loading and lazy loading with lazy keyword. In the next session, we will understand the differences between singleton and static classes, and also we'll try to create one real world example as case study using this singleton design pattern. Thank you for listening. Have a great day.